Alright guys, here's video 3.2, graphing polynomial functions for the lesson we covered on Tuesday. So let's go over a few of the notes I gave in class, and I put a little summary right here of everything I gave to you in class. If you want to pause it and copy it all, and then I can explain to you what we talked in class. In order to graph a polynomial function, there are 4 things we need to know for sure. And here are the 4 things we need to know. I need to know the degree of the function. Is it going to be an even or an odd degree function? Because we need to know the general shape of that function, and the general shape is only determined if I know the degree of the function. Also, I need to know the leading coefficient. I've been using abbreviating LC here to meaning leading coefficient. So I need to know the leading coefficient. Is it a positive leading coefficient or is it a negative leading coefficient? I need to know that because, again, just knowing if it is even and positive or odd and negative or vice versa, I can determine the general shape of my polynomial. These 2 pieces of information give me the general shape, which is a good idea before I get started. But I need more specific so I can graph the function 100% correctly. And then I need the x-intercept, so I want to graph the function precisely. The x-intercept is found by set the y value equal to 0. And then when you're done setting the y value replace it with 0, you're going to set each factor equal to 0. Every single factor equal to 0, and then you're going to solve for x value. That's how you get the x-intercept. You want to know exactly where the polynomial is going to touch the x-axis. Now, sometimes an x value will happen more than once. That means, so I'm going to cross the x-axis at the same exact spot twice. Well, that is something that we need to learn about, and that was what was referring to as multiplicity. If you're going to if you touch the x-axis at one value only once, then you're crossing. But if you are going to get the x value answer more than once, twice, then there's no way you can cross it and cross it over again. That would be being just a bounce off of it or a tangent to it. So if it is a multiplicity of 2, which is an even value, there's no way you can cross it twice. We can just call it is tangent. You touch it and you move on. Don't cross it. So that's how you get all the information for the x-intercept. There's a lot of things about the x-axis. Now we also want to know precisely what is the y-intercept of the function. Just like a line has a y-intercept, a parabola has a y-intercept, a polynomial will have a y-intercept as well. To find out the y-intercept, you set the x values equal to 0. So every x that I see on my polynomial, I'm going to replace with a 0, and I'm going to solve for the y value. Okay? So those are the steps that we're going to follow, all 4 steps every single time. So let's take a look at a couple of examples. I'll do 2 examples for you to help you finish your worksheet number 2. Let's go ahead and start with number 1, and then we can move on. Now I'm going to keep my little set of notes right next to me here. This little set of notes I gave you, I'm going to keep it right next to me here to guide my thoughts. And that's what I suggest you do when you do your homework. So first let me find out the degree. To find out the degree of the function, you block it out, or you pretend that you don't see this -2 here, this +5, and this -1. I'm going to pretend I only see the x values. So it's going to be x times the x values. Whoops, I missed my multiplication. So x times x times x is x cubed. So the highest degree of this polynomial is going to be a 3, which is an odd function. Okay? So we know it's an odd polynomial, but we also need to know, they don't ask here, but I am going to also add another piece of information, which is the leading coefficient. So I'm going to write LC for leading coefficient. I need to know the leading coefficient of this function so I know if it is an increasing function or a decreasing function. For the leading coefficient, you look at the numerical value in front of every single one of the variables, not in the back, in the front. So I have an invisible 1 in front of the x, times the invisible 1 in front of this x, times another invisible 1 in front of this x. So I have 1 times 1 times 1, so the leading coefficient is just a 1. Okay? If I had a number 2 in front of this x, and a number 3 in front of this x, and a number 1 in front of this x, so it would be 2 times 3 times 1. All right? So the leading coefficient is 1, so it's positive. I have a positive odd function. If you take a look at your little cheat sheet over here that we created, the little flashcard, you will see that I have an odd degree function with a positive leading coefficient. So we know the general shape of this, okay? We will have probably a bounce or 2 intercepts, and we'll have the y-intercept. So it could be 3 crosses or 1 cross and a bounce. Could be a combination of anything here, but it's gonna look like this. Okay, then the end behavior pretty much comes from our little flashcards. We know that we have a positive odd function. That means we started low on the left, we started low at negative infinity, but on the right we end up high at positive infinity. That's how you increase from negative to a positive infinity. You are increasing function. Then they ask for the x-intercept. The x-intercept, I have my little notes right next to me, says set the y value equal to 0, and then set each of the factors equal to 0. That's exactly what I'm going to do. I'm going to set x minus 2 equal to 0, x plus 5 equal to 0, and x minus 1 equal to 0. And then it says solve for the x values. So I'm going to solve. I'm going to add a 2 to both sides. I'm going to get x equals 2. There we go. I'm going to subtract 5 from both sides. I'm going to get x equals negative 5. There's another x value. And it says x minus 1 equals 0. You add 1 to both sides. You get x equals 1. So there we go. Here's our x-intercepts. Because the number 2, x equals 2, only happened once here in my solutions, multiplicity of 1. So multiplicity of 1, I don't know where to write it. Let's try right here. Multiplicity of 1 for this one. Negative 5 only happened once is also multiplicity of 1. And x equals 1 only happens once, so is also multiplicity of 1. So they only happen one time. That means we're going to cross the x-axis at those values. Now they're asking us to solve for the y-intercept. For the y-intercept, according to the notes I just gave you over here, it says set the x values equal to 0. So I'm going to grab my function y equals, that is exactly what I'm trying to solve. What is the y? But I'm going to replace every x value with a 0. 0 minus 2 times the quantity of 0 plus 5 times the quantity of 0 minus 1. So I pretty much went to my x values over here and I replaced them with 0 values, okay, x being 0. And then you just multiply negative 2 times the 5 times the negative 1, and you get that you get negative 2 times the 5 times the negative 1, which equals a 10. So my y-intercept, when I plug in 0 for x, I got a positive 10 for y. That's exactly what you get. That's your y-intercept. Okay. Here it would be 2, 0, negative 5, 0, and 1, 0. If you want to write it as an order pair, 2, 0, negative 5, 0, and a 1, 0. So those are your x-intercepts, and here's your y-intercept, the function. All right, so now let's actually put all this together in a graphing case. All right, let's see something with the multiplicity is not just a one multiplicity to see what happens. Let's go ahead and solve number 4. Because I need more room, I am going to solve all the information on a separate piece of paper. I'm going to rewrite the question right here. F of x equals 2 times x plus 4 squared times the quantity of x minus 2. So I have this problem right here. Let me go ahead and get all the information I need out of it, and then we'll come back and graph it, okay? All right, first we need the degree, and then we need the leading coefficient, and then we need the x-intercept, and then we'll finally get the y-intercept, okay? So those are the 4 pieces of information we needed. The degree. Pretend you don't see any number. Forget about the 2, forget about the 4, forget about the negative 2. So if you cover it all up, all you're going to see left over there is a x squared times an x. Okay? You need to cover the, please do not cover the exponent because we need the exponents. So cover the 2, pretend you don't see the 4, and pretend you don't see that. So if you cover all, you see x squared times an x. According to the rule of exponents, when you multiply the same base, you add the exponents. So you get an x cubed. The degree of this function is a 3, which happens again to be an odd function, just like our example number 1. Now the leading coefficient, you are going to multiply all the numerical coefficients of variables. So I have an invisible one here and an invisible one here. So I'm multiplying 2, which is also a coefficient, 2 times 1 times another one over here. So 2 times 1 times 1, which is just a 2. Okay, so in degree, we are worried about exponents. In coefficient, we are worried about leading coefficient, we're worrying about coefficient, numerical values in front of the variable. So we got that is an odd function with a positive leading coefficient. Now we know that the general shape of it is supposed to be from negative infinity up to positive infinity. That's the general shape of this function. We just know this. Now we just need to know the specific location of their x-intercepts and the y-intercept. For the x-intercept, we're going to set the y equal to 0. So instead of an f of x, I'm going to write 0 equals 2 times the quantity of x plus 4 squared times the quantity of x minus 2. And I'm going to go ahead and set each of the factors equal to 0, just like my instructions on the notes said. So I'm going to get 0 equals 2 times, I want to rewrite this squared value as, just like x squared is the same as x times x, I'm going to write this quantity twice. X plus 4 times x plus 4 times x minus 2. So I just rewrote so I can see every single factor. I rewrote an x plus 4 squared as two sets of x plus 4. I am not going to set 2 equal to 0 because there's no need for that. I know that 2 does not equal 0, and there's no variable on 2 anyway for me to solve for x. I'm going to set every single factor equal to 0. So x plus 4 equals 0, x plus 4 equals 0, and x minus 2 equals 0. Then I'm going to subtract 4 from both sides. I'm going to get that x equals negative 4, which happens to be again here, subtract, and you get x equals negative 4. And then here you're going to add a 2, and you get x equals positive 2. Now let's check multiplicity. It looks like I got x minus 4 twice. Something interesting is going to happen at the x equals negative 4. There's no way I can cross it going up and then come back and cross it down. So this is going to be multiplicity of 2. That means we're gonna bounce right off of x equals negative 4. Okay, because the multiplicity is 2, we're going to bounce right off of x equals negative 4. Here x equals 2 only happened once. As you can see, there's 3 answers. X minus 4 happened twice, and x equals 1 only happened once. So the multiplicity is 1. That means we're going to cross at x equals 2. So now we know where we're bouncing, where we're crossing. So if we take a look at our general shape, we know exactly where we're going to be crossing, where we're going to be bouncing. Now let's find out the y-intercept. For the y-intercept, we set the x values equal to 0. So we go back to the original function. It says f of, instead of x, I'm going to put a 0, because that's exactly what I want to know. 2 times 0 plus 4 squared, and then 0 minus 2. That's what my y value is going to be. F of 0, when I plug in a 0 for x, I got 2 times 0 plus 4 is a 4, and you square it. And 0 minus 2 is a negative 2. So let's finish calculating that using the order of operations. We got to do exponents first, then we multiply. So the y value, when I plug in a 0 for x, is 2 times 16 times a negative 2. So the y value, f of, when x was 0, is 2 times 16 is 32, times a negative 2 is negative 64. So there is my y-intercept. When I plug in a 0 for x, I got negative 64 for y. That is my y-intercept. Now we have everything we need. We have exactly where the y-intercept is. We have the x-intercepts. Now we can go ahead over here and graph it. I'm going to put the notes on the side here. You can't see it, but it's right here on my side. So I'm going to label right down here negative 64. That's my y-intercept. I'm going to label at negative 4, negative 1, negative 2, negative 3. Negative 4 right here, it is a bounce. Negative 4 right there, it is a bounce. I'm not going to cross it. And x equals 2 is right here. I am crossing it. So somehow I'm supposed to cross here, come and touch my y-intercept, okay? And then go and bounce off of this negative 4 and go back down. Okay, we're going to cross up but cross down. That means a bounce. And my function is going to be facing down, but over here is going to be heading towards the positive infinity. Exactly what we had decided in the beginning. It starts from negative infinity, it's going to bounce off of a negative 4, cross over a negative 64, and cross through x equals 2 and go towards positive infinity. So, and that is the importance of knowing x-intercepts and y-intercepts, so we know exactly the direction of our function. Okay? So I hope this 2 problems helps. And it's only a 15-minute, 16-minute video there for you. So hopefully these 2 problems help. It's the same process over and over and over. The same 4 things we need to know. So if you please take a look at this set of notes right here. It's a little cliff note here. The degree, the leading coefficient, the x-intercept and the y-intercept is the same procedure every single time, and then graphing it. Okay? So pay attention to every detail, and then you'll be able to solve the other problems. So I have already done in class all these 4 problems right here in class. So I hope you can go ahead and finish this worksheet so we can move on to the next lesson. All right, good luck.